Hello everybody, in this video we're going to talk about one article of the magazine, Cross Country magazine, about thermals. This article was written by Ferdinand Vogel, a very experienced cross-country pilot, and he gave us some advices about how to identify thermals and how to do cross-country flights. First of all, he tells us that novice pilot never knows how to find these thermals, and they believe that experienced pilot has magical powers to find it, like special sunglasses to see the thermals. But it's not magic, it's just some theory and technique to identify where is more we have more probabilities to find these thermals. He tells us that try to imagine the thermals as a drop, but this drop don't goes down, it goes up. He tells us that we have to imagine the condensation drops that flows as through a fabric of the tent. These drops try to find the best way to canalize, to join together, and then when they find something that triggers it, it goes down. The same happens with the thermals. That is hot air that try to get together, canalize, and when they get to something that triggers it from the ground, the thermals appears and this heat goes up. Not all the terrain has the same potential to create thermals. Patrick gave us 5 characteristics to check, to try to identify where to look for thermals. First of all is the angle, if the solar angle. When we have 90 degrees direct radiation, we have more probabilities to get thermal because this terrain get hotter. Then absorption. Dark surfaces conserve more energy than light ones. Dark surfaces are better because they get more hot and they conserve more the heat. Third, the heat capacity is the characteristic of a surface to conserve this heat. Not only to get hot quickly, but get the heat and then conserve it. Don't lose it. Fourth, the time that is this surface is exposure to the heat. And number 5, the conductivity. Higher surfaces are better because they have more area to expand the air. We're going to see it with example. For example, we think that a rock's face is very good to find thermals, but the angle is not good because normally they are vertical. Sometimes we have low surface and conductivity, and they get hot quickly, sure, but these rocks don't conserve the heat so well. By the other hand, a dry grain field is very good to find thermals because they're horizontal, so we have 90 degrees angle, solar angle. This kind of terrain get hot and conserve the heat because we have air between the grain that conserve the heat of the radiation, and we have a lot of and huge areas of fields, so it helps us for the conductivity. Another thing that we have to imagine when we are looking for thermals are the hot plates, these areas where we think that they are going to create thermals, and then we have to imagine that there are like 2 rivers. The first river is the air, turbulent, fast, and very changed, low altitude wind. In this area we are going to find strong thermals, difficult to turn, maybe broken thermals. But once we have a higher level, we have like a smooth river. In this area, in this altitude, normally thermals are wide, are easier to turn, and more organized. That's why when we're higher, we have more chances to find good thermals. When we are landing and we're low, it's harder to try to find the thermals and use them. So once we have the heat in the terrain, we have something that triggers to make a thermal. And sometimes this trigger is just the change of an angle. The mountains has different angles, and when we have this change of angles, sometimes the heat that is like stick in the mountain releases from the mountain and create a thermal. So we have to try to find the places of the mountain that we have different angles, and that's why the author of this article create a theory of the triangles. We have to visualize triangles in the mountains and try to find these angles that trigger the thermals. He says that the best triangle we can find is a equilateral triangle. When we have triangles too wide, they make very smooth thermals, and sometimes the thermals or the heat doesn't convert in one zone. When we have, for the other hand, sharper triangles, that thermal is too strong or too disorganized. So the ideal is the equilateral triangle. So we have to try to find the hot plates, try to visualize how the wind is, how the wind change the thermals, and then try to identify the angles of the mountain to find the triggers. And then we visualize all this, we can try to we can imagine where the thermal is. And finally, Vogel tells us that most pilots really don't understand how the speed bar, how the accelerator works. This accelerator is not linear. For example, if I accelerate with my feet 50%, doesn't mean that I am actually accelerating 50%. At the beginning, I accelerate like less than normal. If I put 50% of accelerator, I accelerate, for example, 30%. Once I accelerate more percentage, the real accelerator increases. For example, to get the last percentage of acceleration, to get the 100% of acceleration, I have to step the speed bar until 100%. If I lose 2 or 3 centimeters, it's a huge difference. These centimeters can mean 20-25% of my total acceleration. So if I want to really accelerate 100%, I have to do full speed, full acceleration with my feet, and get sure that the pulleys of the bars get together. And one final recommendation is to use the speed bar slowly. Don't step it fast, because if we accelerate too fast, we are going to lose a lot of altitude because the glider enters like in an unstable situation. If I accelerate gradual, slowly, the technique is better. And finally, the author recommends to try to visualize these triangles, these angles, trigger angles or hot plates in several places, not only once. I have to try to imagine a plan or B plan and C plan, and then for all my cross-country flight. Okay, that's all for this article of Cross Country Magazine. You can find it, the complete article in this magazine, and see you in the next video.